So hello guys, I'm back for some 8 hours coding questions. Let's solve some DSA questions more. So yesterday we solved a lot of questions, and today I'm thinking of solving more of a kind of dynamic programming questions, graph data structures questions, and all those questions. So today will be a great day solving all those questions. I hope you guys are also continuing with me and solving questions as much as possible. So let's deep dive into this and see what else can we do. Okay, so today I'm thinking of solving some dynamic programming questions. Maybe I'll even go for greedy algorithms, graph data structures, and algorithms. So mostly I'll be focusing on these dynamic programming and graph data structure because I think I've practiced a lot of the previous questions in the previous streams, but right now I haven't practiced much of a dynamic programming questions of a graph data structure questions, so it might take some time for these questions to solve. I might be possible that I'll not be able to solve very much of questions, but still I'll try my best to solve as much as I can because dynamic programming questions are really good. Graph data structure questions are really good. So let's do it. Let's pick some DP questions. Let me start my Pomodoro timer. Okay, let's go. You have some repeating subsequences. I have already tried these questions. I don't know why I haven't submitted it, but repeating subsequence. Let's try this question. Why I was not able to code it. Let's see what's the problem. It's saying that we are given a string A. Check if the length of the longest repeating subsequence is greater than or equals to 2. Uh, I also solved the lead code question today. I was able to solve 3 questions, but the third question was a little trickier. Okay, so now we are given a string A. We need to check if the length of the longest repeating subsequence is greater than or equals to 2. Longest repeating subsequence is greater than or equals to 2. Longest repeating subsequence is defined as the two subsequences have the same string character at the same position. Okay, any ith character in the two subsequence shouldn't have the same index in the original string. Okay, note if the subsequence length is greater than or equal to 2, return 1, else return 0. Okay, let's take an example and see how we're gonna approach this question. So the input is AB. The output is 1. AB is repeated. The two subsequences have the same string characters at the same position. Any ith character in the two subsequences shouldn't have the same index in the original string. Now in the second example, in this example we can see that AB and AB is repeated. So we returned output as 1. In the second AB BA, you can see AB, but there is no more AB and neither BA. Zero, 1, length of repeating. Okay, I have to return 0 or 1. 0 is the length of repeating subsequence which is lesser than 2, and 1 is the length of repeating subsequence that is greater than or equals to 2. That means what? If that means if we have AB, if we have this ABBA, there is one substring that is repeated. This is the one repeated, or we can also take this B and B. Hmm. The given A string is 100. So how can we think of approaching this question? Maybe we know AB. What can be the brute force of this? If the subsequence length is greater than, longest repeating subsequence. I just need to know like whether if I say this A B C, and maybe I'll take A B and A B C, whether this has something or not. Is there this question, is it there in lead code also? Repeating subsequence. Repeating subsequence. Okay. This is also very much similar to the same question. Maybe what is the trick? You are given a string s of length n and an integer k. These are the two things that I have been given. You are asked to find the longest subsequence repeated k times. Just a second. Yeah, I'm back. Sorry, I got a call. Okay, so let's understand this question. You are given a string s of length n and an integer k, and you are tasked to find the longest subsequence repeated k times in the string s. A subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining character. A subsequence is repeated k times in the string s. If sequence into k is a subsequence of okay. For example, BBA is repeated two times in the string this, because the string BBA constructed concatenating BBA two times is a subsequence of string BBA and BBA. Okay, so for example BBA, so this was my string BA, and what's it is saying BBA and BBA. We have two subsequence which are same. So if I pick this BA and again BBA, we got a substring BBA and a substring BBA. Return the longest subsequence repeated k times in the string as if multiple subsequences are found the lexicographically largest one. If there is no such subsequence, return an empty string. Okay, now I need to find uh, in this we have been given a string. This is my string. I need to find a subsequence that is repeated twice here. So you can see LET and LET is is a two subsequence that has been repeated twice over here. So I'll be returning LET. Now BB and K2. So normal 1B is there which is repeated twice. AB, there is no subsequence which is repeated two times. So what I can say here, I need to return the longest possible. Okay, so let's break it down into smaller pieces and see what can we do. Let's remove code for now. I have k as 2, means I need to find a subsequence, largest subsequence, who when repeated we can find them twice over here. So is it possible that I pick LE then T from here and L ET from here? This might also be possible that I'm picking this. नहीं बढ़ेगा चश्मा का नंबर इतना जल्दी नहीं. So this might be possible. Let's try and run this and see if what will be our answer. I'll add one more test case. Let's add LE LT ET. नहीं बढ़ेगा. Case twice. Let me return run this. Okay. Oh, okay. So it's not considering this as LET and LET. It's not LET and LET. It's going LE and then L and E. Cool. This will reduce my uh, complexity, I think, a lot of solving this question. So now we can think of some approach. Let's take this only as an example. From wherever my substring is ending, okay, wherever, from wherever my substring is ending, I need to check. So if I pick this as a substring, let's suppose if I pick this L as our substring, well, now I need to know, like, this is my substring and I need to know, is there L present in future of this string or not. So I can see there is one more L. So the K, I can see the L's value is twice. Either one of the brute force approach is find all the subsequences of this and keep it in, I'd say keep it in a map, and whatever the count will be, if somewhere we find that it is greater than or equals to a subsequence is a sequence repeat. Okay, now if I say that this LE and I have one more LE, let's take LE, 3 LE. What will be the output in this case? At minimum, repeated minimum K times, it can be more than K also possible, because LE is repeated 3 times, but still my expected answer is LE. So and my the maximum it can go is 2000. So it will be if I'm picking this or I'm not picking this. Now initially what I'll say, if this index matches with, I created L. Now let's take LE as in our answer. So if we are picking this LE, what we can see here, I need to find another subsequence after this which contains LE, which also has LE. So I need to compare this index with L. So it matches. I'll move my index over here and I'll go to the next. Now if are they matching? No, they are not matching. I'll not pick this. Are they matching? Yes, they are matching. So I can find one of the possible answer is LE also. Correct. Now LEL. We can also try for LEL. So I can find no L after this. So there is nothing we can do. So LE is the maximum that we can return. So we need to return the string. We need to keep track of this string, whether this string is possible or not. So the first time I'll be creating a string, and the second time I'll be finding a string same to this string. So there will be some flag which will help me in setting and in not setting. If it is 0, I'm creating a new string. If it is 1, I'm finding that string. That's what my thinking is going right now. That flag will help me in creating my answer. Maybe we can try to code it if it is possible. I'll think of something. I'll pass k. Now I'll pass a flag which will when 0. I'll pass an index also and one more index. Maybe I'm not sure if I'm forming the answer correct or not. So this will pass a string. Just give me 1 minute. I'm getting a call. Back. Okay, so we were coding this. This will accept string ampersand s. I'll have k, whether it is repeating k times. I'll have a sidx, which is my string actual main strings index. I'll have another thing which is my flag, and another which is my should I pass an empty string also? I don't know if the time complexity will help me or not in this case, but let's see. sidx is my string index, and this idx will be my str idx. So maybe str idx and in flag. if my SIDX goes beyond s or equals to s dot size, I'll be returning an empty array. If it goes beyond, I'll return an empty array. If it does not go beyond, so I need to check my flag first. If my flag is 0, then this is the first time that I'm creating a string, a substring. So I'll pick this and I'll tell that okay, search this substring next, or I'll pick this and I'll tell that okay, do not search this, create more. There will be to solve method. First will tell me s, the second is k will be reduced by 1 because I'm finding this. If I want to say that okay, search this string, then my k will reduce. Also, if the base case will handle um, or my k becomes 0, k minus 1 str, this str will contain str plus s of sidx. कोई बात नहीं आराध्या वर्मा, तुम्हें थोड़ा बड़ा होना पड़ेगा फॉर दिस. We are not as much capable in coding right now. We're just in 10th standard, so grow more, then you can understand this. Now my SIDX will increase to one more. Now my STR-IDX will not increase. STR-IDX will not increase. My flag, okay, I'm telling that search this substring, and the same thing will be copied, and I'm telling you that do not search this substring, create more. Now if my flag is 1, searching this substring, now I need to increase my STR-IDX and not my SIDX. SIDX will stay as it is. STR-IDX will start from SIDX, either or even beyond SIDX. So STR-IDX is on. So I need to check if S of SIDX is equals to STR of STR-IDX. If they match, then increase. This is getting a little trickier. I need more insight on this question and I won't be possible with this. Maybe I'll take some hint and that will help me. Facebook. Okay. The length of the longest subsequent does not exceed n divided by k. Do you know why? You think the length of the longest subsequence does not exceed n divided by k. N is my length divided by 2. Obviously, it will not increase than that. Correct. That is one more insight that I found, that it will not go. Let's lead code k equals to 2. If there is k2, now we know the string length is 1 2 3 4 5 6 7 8 9 10 11 12. 12 divided by 2, that is 6. The maximum subsequence that we can create, one maximum subsequence is of length 6, because we need 2. That's why 6 plus 6, that is total of 12. That might be possible, one of the possible, like let and let. We can see if k is 2, I can say that it will be divided into half, 2 half. So total length by 2, that is 3. Now what that will give me, what's the insight that we can take from here? That's fine, that it will not go more than that. So I have to go till that index length only, and beyond that my k will reduce. Even before that also my k can be reduced. My k will have to reduce. So whatever string that we made here, hmm, this is a really nice question. How we can approach it? How we can approach? What more can we find? What more insights can we find? Like let's lead code is 1 2 3 4 5 6 8. 1 2 3 4 5 6. It cannot go more than this. If I change the color, it cannot go more than this. This half and this half. Now 1 is here, 1 is here, means if two, there are total 2, 1k, one substring I have to find from here and one substring I have to find from here, which are equal, something like that, right? Okay, this is this is a good insight, but how we can know? But mm, if I take this as example, LEMNOP 1 2 3 4 5 6 T and LET. So LET, even uh, QR. I can see LET and LET over here. Even that defies our perspective, what we were thinking, what we got the insight of. Hmm. Find the characters that could be included in the potential answer. A character occurring more than or equal to k times can be used in the answer, up to count of character by k times. Right, huh? That the length will never increase more than 6. But it can be anywhere. The length will never exceed. What insight are we getting? Length will never exceed. Uh, what what more can we find? Exceed n by k. That is one insight. Now the second insight is the character, the only character that can be taken as a potential answer is who is repeated k times or even more than k times. So you can see L is repeated here 2 times. So I need k to, so L can be in our potential answer. Now E is repeated 3 times. E can also be in our potential answer. Now T is also repeated 2 times. T can also be in our potential answer. No, S cannot be in our potential answers, right? Because it is only one repeated once and we need two. So that cannot be kept in our answer. That is perfectly fine. Oh, now what we can think from here. Now if E was 4 times, now if there is one more E would have been 4 times, then I can count this as 2, means what, 4 divided by k. So 4 divided by 2, that is 2. 2 times E, 2 times E can be taken. That is also correct. But if we even keep these in maps, we don't know what's the order. These all four is can be a potential answer, but we are not 100% sure that this will be our answer. What more insight that can we find? What more insight we can find here? Means count of character is greater than equals to k times so n count count divided by k. That is the second insight. I need to find all more insights. um, I'm still not able to properly find how we can do it. Still need more insights. What else can we take? What else can we find? Let us lead. Let's take hint 3 also. Try all possible candidates in reverse lexicographical and check the string for the subsequent condition. What it is saying, try all possible candidates in reverse lexicographic order and check the string of the subsequence condition. For the subsequence condition, reverse lexicographic means bigger to smaller and check the string for the subsequence condition. Mm, 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 mm. AI, what approach can we use here? What it's saying, lexicographically start from bigger to smaller. L E T L E T. Why it's LE? Why not LET? Maybe I'll check the solution. Answer is not so long. Insights and optimization. Fundamentally, this problem is not that hard. The hard part though is to make the solution fast enough. K can go to 2000. The key insight was that because of the relation between K and N, see constraint section, our subsequence cannot be longer than 7 characters. You can find my original solution in the comments. With all those inside, I redid my solution to make it simpler and efficient. Original DFS solution accepted after number of optimization. Don't have any editorial. The key to solve this problem is to look carefully on the constraint. N is greater than 2 and lesser than k into 8. This constraint looks very strange. Let us understand what does it mean. In fact, it means that k is greater than n by 8, which means that we can have no more than 7 elements in our answer. K can be greater than n by 8. N is going up to 2000. K can be greater than n by 8. No more than 7 elements in our answer. Why we cannot have 8 or more? Because then we just do not have enough symbols. If we take 8 symbols with frequency k, take so-called hot symbols only such that the frequency. Notice that if we have frequency k comma 2k, we take one symbol. If we are in 2k to 3k, we can take at most 2. It's still a little bit of confused. Maybe count the number of times subsequence occurs as a substring of s. As for the recursive function REC, it tells us whether or not subsequence occurs at least k times in s. If it does, then we can try making subsequence longer by appending a to z and seeing if it works. Now recursion, I have an empty, I have s, I have k. I have a best string that we can see so far. If count oc substring, comma s is lesser than s, then return. If sub dot length is greater than or equals to best dot length, and then sub is greater than best, sub is equals to best, may we are adding sub. We are iterating characters from a to z. Recursion substring plus c, adding this character. Oh, okay. What he is doing is creating a substring and checking how many times that substring is present. It cannot go more than 7. How he handled all those things in so precise way. It's really good. This solution, it might work or might not work, doesn't matter the regarding time complexity, but I think the intuition behind this question was really good. How he picked each character he is adding in the substring and he calling this string. I'll fall back, add a with a b c d f and then a b and check whether every string is present or not and how much count does it have. But where are we stopping this? The substring goes lesser than k. It's by default it is handling that part, which is what, 7, that we had an insight. Okay, his logic is something very nice and precise, I would say. Mm, what he is doing, he has an empty substring. He created an empty substring. Let's take this as example. le t l t e let. So this is an example. What he is doing, he created an empty substring. He added as l in its answer. Now he checked L is there. Okay, L is there. The count of L, total count of L, how many L's are there? It's 2. So my K is also 2. So we can say that this L is one of the possible answer. So he kept it in best L. Now what he did, he added this again. He added one more string again. Maybe after this he's iterating from A to Z. He's adding one by one character each after this. Like this will range from A to Z. This will be replaced by A, B, C, D, Z. Similarly, this will also be repeated from A till Z. If we found LA, suppose we found LE, we found LE. LE is twice. LE and LE is twice. So we increased the count. We we added in our best. So what can be find from here now? LE, suppose the next string is handling from A. Now this insight is really insane, that if N and K relation, now N and K range from 2 to 2000, N can be greater than or equals to 2. This is our N and K range. And N is lesser than K times 8. So N K is greater than N times 8 and can range up to 2000 by 8. Like this will be 250. How is saying that K cannot be more than 7? That is also one of the thing that I need to know. I need to know why. This is one of the solution that I understood, and this is really great solution. The only thing I didn't understood is this constraint. It's saying N is lesser than K times 8. This constraint looks very strange. Let us understand what. In fact, means that K is greater than N by 8, which means that we can have no more than 7 elements in our answer. Why? Why no more than 7 elements in our answer? K can be greater than N by 8. N is ranging till 2000. This is what description is saying. N and K, they both are ranging till 2000. K is greater than 1. which means that we can have no more than 7 elements in our answer. Because then we just do not have enough symbols. If we take 8 symbols with frequency k, in total we take 8 into k. Such that that have frequency k at least. Notice that if we have frequency k to 2k, we take only one symbol. Let's take k as 1 to 2. If it is 1 to 2, we take one symbol. If we are in 2 to 3, we can take at most to 2 symbol. For substring we can have, for example, for hot we have A, B, B. We have the following candidates A, B. That we need to create all possible combinations, and for each combination we create all permutations. Only sort all the candidates. The insight is not very much clear, but I don't know why k cannot be more than this. But what I understood is actually very good. This can be applied over here also. The same thing. This is small. I needed to take care of k is equals to 2 only. 0 and 1. Okay, 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 okay. Nice. So this is a good question. This is also a good question. If I can solve this, I'll be able to solve this also. This is just a subset of this part. Okay. I think I'll code this after a short break of 10 minutes. After the break, we are ready to code. Let me change it. This is the first save. sorry, I went to eat my medicine, so it was a little late for me, but no, it's okay. Okay, so let's just solve this question and see how the things comes up. I'll call this call a solve method, which will take an empty string, also this s and k, and I'll be returning the I'll say best string. I'll be returning some best string. So I'll be let me declare this best string best string. Initially it will be empty. Now this will be a void solve method which will take substr the string s and an int k. Now what I need to do currently, I need to check whether this substring is present in s, and if it is present, then how many times it is present. And if it is greater than k, then we can further move and add one more character to this substring. If it is lesser than k, then adding one more character to it won't make any effect. So if substr dot size, okay, not substr, the check method, check check occurrences of substr in s if it is lesser than k, and then I'll simply returning. If it is not, then I need to check if the length of this substring is greater than my best string. If substr dot size is greater than my best string, then best string will be equals to this substr. And what I will do, I'll iterate over a for loop, which will be a character. I'll start from character ch. I'll start from z. My ch should be greater than equals to a ch minus minus. Now this will do what? This will call this solve again with substr plus this new character with s, and k will be as it is. Now this check occurrences, it will be returning integer type. This occurrences will do what? It will take this substr string array string substr, it will take this string s, and it will do nothing. Now I need to check this, whether how many times this substring is present in this s. So int I is equals to 0, maybe low is equals to 0, and 1 will be count equals to 0, and one more. Now while this I is lesser than s dot size, I will move forward. Now if my low is goes more than or equal to substring dot size, I'll do two things. I'll increase my count plus plus, and I'll set my low back to 0 again. Now here the condition will be, if my substr is equals to substr of low is equals to s of I, if they both are matching, then my low will be increased. If not, then only my I will be increased. Now I will be returning my count. The string dot size, it's best. The second, okay, expected was B, but it didn't come. But it should have. What I did, I have an empty string. I started from Z to A. I reduced every character. I added Z to this character. Check occurrences. The occurrences will be lesser than K. It will return, it will add Y till there, it will add B. Now this low is substring contains B. If low is greater than or equal to substring dot size, substring, no, low is at 0. If substring of low is matching with s of I, I'll increase my low plus plus, even my I plus plus. low went beyond substring dot size, I'll increase my count with 1, and low will set, I'll set low with 0. Substring of low is equals to s of I. I'll increase my low plus plus. Oh, okay. Now let's see if I submit this. Nice. Okay, so this was really a good question. I would say the insight for this question was, I I every time forget this thing. If I have been given a character, if there is a string, there are, I can make change these strings from A to Z, from A to Z, from A to Z. I can do these all things, but I every time forget these things. I need to remember these things, so that I should be able to do it more properly, think more properly. This was really good. Now the same question is here. Check if the length of the longest repeating subsequence is greater than or equal to 2. It's longest, if the subsequence length is greater than or equal to 2, return 1. The length of the longest repeating subsequence is greater than or equal to 2. Longest repeating subsequence, the two subsequence have the same string character at the same position. Any ith character in the two subsequence shouldn't have the same. Means I need to find the longest repeating subsequence, and that if it is greater than 2, I'll be considering that in our answer. Maybe this is only the solution for this also. The only thing here we have is k, but there we won't be having k, we will directly be having 2. It's lesser than 2. It can be more than 2, but if it is lesser than 2, I'll return. My k is something like this. I won't be passing k here also. Let's keep this as s. Don't pass k. Now return base string dot size is greater than 2. If this is the case, then return 1, else return 0. Uh, I have k. My function returned 0. Maybe I'll see out best string here. Obviously, in this case, AABB. What does this even mean? The two subsequences have the same string character at the same position. Given a string A, check if the length of the longest repeating subsequence is greater than or equal to 2. Longest repeating the two subsequences have the same string character at the same position. Any ith character in the two subsequences shouldn't have the same index in the original string. The subsequent length is greater than or equal to 2. This question is not very much clear. I don't know. In AABB. Expected return value is 1. My function returned is 0. Obviously it will return 0. First, AB is repeated twice. In second example, B is repeated twice. But the length is, there is no repeating subsequence. I don't know. Test case understandability. That if we have two subsequences, then only the ith character of both must be from different indices. We can form two subsequences using s of 0 plus s of 1 and s of both have the indices of the first and the second character different. So it's alright even though s of 1 occurs in both. AB and AB. AB, AB, AB. Any ith character in the two subsequences shouldn't have the same index in the original string. This point is telling me what? The two subsequences have the same string character at the same position. I think this is not even the question proper question. Now this is the test case y. We have a expected return value as 1. Which subsequence are we taking in which has a length of more than, and that to repeating? I don't know. I think this is not a proper this was a better way approach question. Dynamic programming. Maybe I'll try with distinct subsequences. Here we are given two subsequences A and B. Count number of unique ways in sequence A to form a subsequence that is identical to the sequence B. Now R A B B B I T. RABBIT. RABBIT. These are the possible removals of the character. If I remove this B, I can make one. If I keep this B and remove this B, I'll make one more. If I remove this, so three characters I can remove. Three possible ways. If I remove this, remove this, remove this. So I can make this from here to this. I only have to remove character. Correct. What I can do here is, see this has a 8, 1, 2, 3, 4, 5, 6, 7. A length of 7. This has a length of 6. We know that we need to remove one character. Sun minus is it is 1. One character from here. So I'll have to remove every possible character. First I will remove R, and if the length matches I'll compare whether they are same or not. If not, then the length of A and the length of B is not more than 700. What we can remove each character and we can check, like the difference can be very much, maybe 7, 8, or even it can extend up to 700. If we need to make this as this and this is empty, so all the characters of this has to be added. If this is empty, then all the character of this needs to be removed. Okay, if I try with B, 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 I, T, R, A, B, B, I, T, can I make it using 2D DP? this R, they are matching. So whatever was removed from here, I'll carry forward here. So 0, nothing I have to delete. If they are not matching, if they do not match, that means what? We have RA and we have R, so we need to remove one. So earlier whatever we had removed, then we had R plus 1 will be whatever we had earlier plus 1, whatever if they do not match, if we have RA, if we have RA and we have R here, then we'll have to add one. We cannot remove any. AR, they did not match the max. This these all will not be considered, right? These all will not be considered only because they are not possible. Now AA matched, they are same, so whatever we had earlier will carry forward that. We need to remove nothing. Now AB they did not match. That means what? RA, we have RAB and RA. Whatever we had here, whatever we had here, both minimum of both plus 1. When only RA was there, how many were needed to remove, or only R was there? Now same thing for this only also. B, they did not match, so whatever minimum plus RABB and RA, so minimum plus 1, minimum plus 1, minimum plus 1. Now we added B also. B and B matched, So what we'll be doing is we'll carry forward this 0 from here. B and B matched. So what is this? RABB, and this is RAB. So we will carry forward this. Still I need to remove one. B and B matched. We'll carry forward this. B and I did not match. So max plus 1, that is 3. RA triple BI. B and T match did not match. We'll make minimum of both plus 1, that is 4. That means what? We have RABBBIT and we had only RAB. So we need to remove these all 4 characters. Now we have again a B. B and B matched. I'll carry forward this. B and B matched. I'll carry forward this. B and I did not match. So best of minimum of these two plus 1. B and T did not match. So minimum of these two plus 1. I B. I and B, if they did not match, minimum of these two plus 1, that is 1. As this is cross, I'll putting 0 over here. Why 1? Because if you see till here we have RABBB and we have RABBI. RABBI. If they did not match, so minimum plus 1, I need to remove one character, but they both are same. If I remove this, it will be RABB, not RABBI. Do I even need to handle the diagonals? Yes, I will have to handle the diagonals. But in this case, what will be returned? RABB B and RABBI. The diagonals did not match. they did not match. T and I did not match. The R A B B B I. It is R A B B I T. It is saying remove only one. So this R A B B I. T T matched. Just said that I need to remove only one character. Let's try for any recursive approach. Maybe this is one of the possible way, but I would not suggest going this way. Maybe I'll go for some other approach. If they matched, I can try something wrong. Hello, Saurav Shekhar. How are you? Long time no see. I need to remove S. I have string S. I have a string B. That I need to make if my I also have to have an index IDX. Now if first of all I need to check if my str is equals to b, I'll return 1. If my str dot size goal is more than, I'll be returning 0. I am removing this string. I'm not removing, not removing. So if I am removing this string, count will be maximum of count comma. I don't need to maximize. Whatever it will return, I'll add it. If I'm not considering this as in my answer, SB will be as it is, STR will be added with S of IDX. Even we can keep B. This exceeded the memory limit. If IDX is greater than, this time it exceeded the time limit. Okay, I think I'll have to check the solution for this, and I'll check it after a short break.